Hey, welcome back. It is part two of our wonderful series on solving inequalities by graphing. And with that said, we're going to jump right back into example 5. Example 5 coming up. So I hope you have your notes and take a look at example 5. Whoops, there's example 4 again. All right. So for example 5, it's a little bit different. The way that the function's written out, it is not written as one fraction, it's rather written as two fractions. And so in order to use a sign chart on this thing, you must rewrite this so you can find the zeros and vertical asymptotes. Now you might think that you have all the stuff needed right here. You know, you might see there's a vertical asymptote at maybe -2 and 1, but what is the zero? It has to cross the x-axis somewhere, right? Well, in order to figure out the zero, you have to combine these two fractions as one. So you need to figure out a common denominator, which is x plus 2 times x minus 1. And so you would multiply the fraction by the factor that is missing. So like the first fraction, x plus 2, is missing the factor x minus 1. So I multiply the top and bottom by x minus 1. The other one's missing the x plus 2. So I multiply the top and bottom by x plus 2. All right. Be careful here. Now, there is a minus sign here, so you will be distributing not 2, but rather a -2. Okay, so make sure you kind of group this together. And what we're going to do now is distribute and write this all as one fraction, because the denominators are the same, even though the order switched, but you can switch the order around, it doesn't matter. So if we distribute that -2 in, it'll be -2x minus 4. Distribute the 1 in, it doesn't change anything. So you have 4 terms on the top, all over these two factors on the bottom. Now we're just going to combine some like terms. So you have -x minus 5 on the top is greater than 0. And now, how do we get the x-intercepts? Well, the x-intercepts, remember from I don't know, maybe last lesson? Or actually 2 lessons ago, you get from setting the numerator equal to 0. So you're going to set this numerator equal to 0 and figure out the 0, or the x-intercept of the function. Well, I did something trivial, kind of. I took out the -1, all right? And now you can clearly see that the 0 is going to be -5 here. Well, I did something else that might be a little bit interesting. Because there was a -1 here, I got rid of that -1 times this, and so I flipped the inequality around here. Okay, now that makes it a little bit easier to use the sign chart, because now you don't have this extra negative sign to account for when you're doing the sign chart. Otherwise, you'd have like a negative sign all the time here out in front because of the negative constant. So you could divide away that -1, and that will cause you to have to flip around greater than to less than. All right, so now we got our zeros. Now we know our vertical asymptotes are here, areas where it's undefined, and now we can make our sign chart. Okay, so let's put in a value less than -5, which would be -6. And when you're substituting here, you don't want to go back to this, because it's not going to help you figure out the signs. Okay, it has to be written so it's factored, and so it's multiplications and divisions in order to determine whether the signs are positives or negatives. So I'm going to put a -6 in here, -6 in here, -6 in here, and so I'd have a negative, negative, and a negative. So all the signs there are negative. I have 3 negatives, which means that this region is negative. Okay, next I'm going to put in a number between -5 and -2. So like maybe -3. Substitute it, I get positive, 2 negatives on the bottom. Okay, so this region is positive, because these 2 negatives would cancel. Okay, here I'm going to probably put in 0 if I'm checking it out. So if I put 0 in, I get a positive on top, positive on the bottom, negative on the bottom. So this region here is negative. This region here is usually all positive, not all the time. But you put in, like, say, 2, and everything will be positive. Okay. So now we're looking for where it is less than 0, because remember we flipped around the inequality sign right here. This sign chart is for this function here. Okay, so it's less than 0 where it's negative at, so negative infinity to negative 5, and negative 2 to negative 1. Okay, it's strictly less than, so we don't use brackets. If it was less than or equal to, we would use the brackets for that one. Okay, so before you make the sign chart, you have to make the function into basically one fraction, okay, where you can see the zeros and vertical asymptotes clearly to help you set up the sign chart. Okay, and I even got rid of that negative 1. Okay, now if you didn't get rid of the negative 1, you just have an extra negative sign always on the top. Okay, so it would look a little bit differently, but anyhow, here is example 6. Something similar. Once again, a rational function. We want to see where it's less than or equal to 0. This time we have it all as one fraction. However, it's not factored, so we have to factor it first. So the top, we want to get plus 3. We have minus signs, so that means our signs are different. And remember, you got to check, do the outside, inside, make sure you get the middle term. You know, you have to get 3x here by taking the outer and inner and combining it. So 5x and negative 2x equals 3x. And down below here, okay, it's going to be the same sign and both negative, and this is actually a perfect square trinomial. Okay, so it's x minus 3 times x minus 3. That's why it's written like this. Now, if you want to write it out as x minus 3 times x minus 3, go right ahead. It's just not necessary. You'll have an extra sign in your sign chart. Okay, no need to flip this one around because there's no extra negatives floating around here. Okay, and so we're going to make our sign chart with our zeros from the top and our undefined region. Okay, so now we're going to plug in values. So first, I'll put in like a negative 6. Here on the bottom, you would have, okay, see it's a negative squared, okay, if you put in a negative 6, which results in a negative times a negative being a positive over a positive. Okay, these two negatives make a positive over a positive. If that square wasn't there, the bottom would be negative, and so the whole interval would be negative. Okay, next we're going to put 0 in. Okay, if we put 0 in, we would have a positive here, negative here, and a negative squared, which is equal to a positive. Okay, so this result would be a negative overall because you'd have a negative for the top, but a positive for the bottom. Okay, so this is the fraction bar here. So negative sign on the top, positive sign on the bottom. I think that's probably why they use the parentheses around here, so you can delineate the fraction bar from the sign chart. Okay, so anyhow, negative over a positive. Okay, next region, maybe, 2 and 3. So this is the first region where you'd actually have to put in a fraction to check out. So you'd have to like substitute in maybe 2.5. Okay, if I substitute 2.5, I would end up with a positive here. Okay, next region, 2.5 minus 2 is positive. Okay, on the bottom though, I have a negative. 2.5 minus 3 is a negative value, so it's a negative squared. But guess what? A negative squared is equal to a positive. So all of these end up being positive, and this region must be positive as well. Okay? Lastly, it's going to be all positives when I substitute here. Okay, so it's going to be positive as well. So where is it less than or equal to 0? Well, it's just between negative 5 and 2. And notice I use the brackets because it's less than or equal to and strictly less than or equal to. Okay, so that's not your homework. I'm going to probably post some Math Excel problems there for your homework. Anyhow, I'll think about it. Maybe I will give you some problems out of the book. So just check whatever I put on Classroom there. All right, guys, have a great day, and we'll see you Monday, hopefully. Bye-bye. Have a nice weekend.